All right, I want to work through problem number 4 from section 6.4. Again, we're trying to answer this question here. It says you wish to test the following claim. We have an alpha equals 0.02. We have a couple of means here. The null hypothesis is that the means are equal to each other, and the alternate hypothesis is that the mean from sample 1 is greater than the mean from sample 2. We need to find a test statistic, a p-value, and then see what happens here, kind of make a decision. So I'm going to just kind of walk you through the parts of this that we need. So here are the formulas. We have our test statistic formula. Notice we don't have x sub 1 or x sub 2. We have our standard error formula, and I've already kind of walked through how to find this. And then we need the degrees of freedom on this one. It gets a little bit complicated. So for that, I just wanted to jump over to the original question here. When I get these, I'll just copy these, and you should be able to copy and paste too. Anyway, so when I paste, a lot of times I use paste special because sometimes the numbers don't come across as good for us, and sometimes Excel or this compatibility doesn't work so well. So I'm going to go grab the second set, sample 2, grab them. That's just a standard copy, and then over here, again, I do like to paste special. Some questions work fine always. Sometimes they're a little bit problematic, so I just do this out of habit as often as I can. So here's sample 2. We have those. Now, a couple of things. If I grab this whole thing, notice this is an even number, but down here it says the count is 43. This gives me n sub 1. Now, you can also use the count function, but I find it's just about as useful here to grab these, and here 44. So filling those out. Now for the mean is the old school average, is the function Excel likes. And again, if we grab the whole data set, it takes into account that we have one of those empty here, and it gives us the mean. Similarly here, using the average function to find the mean, and grabbing the data set, we've got those. Again, if you just grab the data set, it does give you this here, but it also stops with the precision there. So I'm going to just go ahead and copy this as the work here. For the second one, you kind of see how the first one in. And then we have the standard deviation here, and these are samples. So we need the standard deviation of the sample. Again, if I snag the whole data set, it gives me that. And then over here, standard deviation of the sample, grabbing this data set here, and we have it. And then I'll just show you the formula again. I have a little bit of work here for these ones. Now this sort of gets it back to where we can figure out the test statistic, and then we have to do a little bit of work there for the p-value. Now there is a bit of a process to this. We have the null and alternate hypothesis. This one is right-tailed. Notice the arrow is facing to the right. So a couple of things to note here. Alpha is 0.002. This is a right-tailed test. And so that's kind of important for when we draw our picture and try to make a case for what is actually happening here. So now I need to figure out the test statistic, the standard error, and the degrees of freedom. So I'll start here. Oops, I used to call it fancy fraction. I'll have fraction 1 here. But this shows up quite a bit. This s sub 1 squared over n sub 1. And so s sub 1 quantity squared over n sub 1. Similarly here, the fraction 2, for the other set, it is s sub 2 quantity squared over n sub 2. And there we have that. It'll give us just a little bit more room right here. So I have pretty much what I need to build my standard error here. So S sub e, the standard error, however we want to abbreviate that, that's the square root of this sum. And I'll just let Excel do all the work here. Add this and this, close it, and I get my standard error. Now I have enough here to figure out the test statistic, so I think I'll do that. our test stat here, again, we need the difference of the means. So x sub 1 minus technically x bar sub 1 and x bar sub 2 divided by the standard error. And we get an error here. I'm not sure what I did. N23. Well, what did I do? We'll just try it again here. So, this guy minus this guy, that should be the numerator, and dividing by the standard error. Okay. Not sure what I did the first time around, but I did something wrong. It's okay to make mistakes as long as we get back and fix them up. So, but now we have the test statistic. Now, this works for this answer here, but to find the p-value, we need to know the degrees of freedom. So, notice here, this is the first fraction plus the second one, and it's squared. So I set this up as the numerator here, numerator, if you will. Anyway, it's this fancy fraction plus the other one, and it gets squared. So you're going to add these guys together, fraction 1 plus fraction 2, and square it. Now, the denominator is a little more. Denominator. There's a bit going on here. I've got 1 over n sub 1 minus 1, and then this fancy fraction and it's squared, and then 1 over n sub 2, and that fancy fraction and it's squared. So I'll start with 1 over, and I could do 43 minus 1 if I want to. I could set this up here and do this guy minus 1. I can also just do 43 minus 1 and call it 42. And I've got to multiply by this fraction, and it is squared. So this is the first part. Now I add to that 1 over n sub 2 minus 1 multiplied by that fancy fraction there, and it is also squared. So this is one I don't think you really want to spend a lot of time doing all of this work with a calculator here. But then we get our degrees of freedom if we take the numerator and divide by the denominator. So here we are at this point, and I have a test statistic, I have the degrees of freedom, and so I have enough here to figure out what my p-value is. Now the p-value, there have been lots of questions on the p-value. This is a right-tailed test. And so let's see here. If I can draw a picture. I've stressed drawing a picture when I've talked to people. Let's see. Okay. So if I go to draw a picture here, my test statistic is 4.4, and this is right-tailed. So if I just do this, I know it's ugly. I got my test stat here, say it's 4.44. I'm looking for this area to the right. This is my p-value. Now it should be pretty small because it's right-tailed. So, go back here. To find the p-value, I can do a t distribution right tail. And I have my test statistic and my degrees of freedom. And I've got that. Now, this is like 0.0000137. As soon as I click off of it, Excel is going to put it back into. But this is kind of a form of scientific notation. Not actually. But anyway, This ends up being less than alpha, and if our p-value is less than alpha, we reject the null hypothesis. So, I'm sorry that took a little while, but there it is, a walkthrough of the problem. Thank you for watching. Let me know if you have any questions.